So now a number line we use to kind of keep track. It's like a visual representation of the numbers as they exist. So if you draw a line in the center, but it doesn't always have to be the center, but most of the time the center is 0. Well, the reason that we choose 0 to kind of be the center of the number line is because to the right of that is the positive numbers, and to the left of it are the negative numbers. Well, how many numbers are there to the right? Infinitely many. The sideways 8 symbol is the infinity symbol. Now that's not a number, it's a concept. It means that we never run out of numbers. 1 gazillion, billion, trillion, gazillion, dillion, whatever, I can add 1 to it. And whatever that number is, I can add 1 to that. And so that goes on forever in that direction. Now, we can do the same thing in the negative direction. And so for inequalities, sometimes there's solutions where we can have more than, or a real world problem where we can have more than one answer. School bus. A school bus can hold more than one person. A big school bus can hold 20 people. You probably should have at least one person on there driving it, right? If you want to get anywhere. So if I were to ask you how many people can you take on a school bus, there's many answers. Well, you could have one person on a school bus, you could have 20 people. Well, do I write 1, or you could have 2, or you could have 3, or you could have 4, or you could have 5? No. What I would say is that on a school bus, if I wanted to let the n equals the number of people on a school bus. And just from a practical perspective, I guess what we could say is that it probably has to be greater than or equal to 1, or 1 is less than or equal to n. And let's just throw a number out there. I think this particular bus holds 45 people. Okay? Well, that's cool. What am I saying? I'm saying that I can have anywhere from 1 to 45 people on this school bus. Now, these are inequality symbols. And it represents a set of solutions. And I could graph this, and it's a lot better than saying, well, how many people could be on the bus? Well, it could be 1, or it could be 2, or it could be 3, all the way to 45. So before we move forward, let's talk about that. Again, on a number line, to the right we have positive numbers and negative numbers. This is positive infinity. This is negative infinity. Now, if I move to the left, my value moving to the left gets lesser and lesser. If I move towards the right on the number line, it gets greater and greater. Now, this symbol means less than. This symbol means greater than. Now my smartboard needs to be calibrated. But sometimes we want to include a number. So if we ever want to include a number, I put a little equal sign underneath it, and that means less than or equal to. And if I were to do the same thing over here, that means greater than or equal to. I really need to calibrate this right side of the board. Okay? So now what does that look like? Well, let's see. Let's do a couple of examples. First example, x is greater than 4. So pretend this is a number line, somewhere over here is 0, and I go 1, 2, 3, 4. Right here is 4. Whoops, I don't want to draw my circles yet. 1, 2, 3, 4. And I want to represent a value greater than 4. Well, we know that anything to the right is greater than. Are we including the 4? No. So to demonstrate that, we put an open circle at 4. And what I like to do, and I think it's better if you have different colored pencils or if you use a highlighter. What I like to do is I like to just go this way in this direction and draw an arrow. Now, if you don't have colored pencils and colored paper, you can just sometimes you can do this and just put it on top of the open circle. Doesn't bother me one way or the other. And when I look at that, so this is how I represent my solution, right? Using inequality notation, and this is how I can represent that information using a graph. But now let's say I'm curious about a value, and we'll say that this value is greater than or equal to 4. Well, again, at 4, I know that my value is greater than 4. But am I including the 4?
Yes.
Yeah. So how would I represent that data? Yes. A filled in or closed circle. So if I close in the circle, I'm letting the reader know, hey, it's all this stuff to the right that's greater than 4, but we're including 4. And lastly, well, not lastly, I guess I could do one more. X is less than 4. Again, somewhere over here on the number line, I have 4. Is there an equal sign in my inequality? No. So what do I do? Open circle, and now I go to the left. Okay? And I suppose, just for good measure, we'll do one more. Let's do x is less than or equal to 4. We get to 4, we include it, so we put a closed circle, and we go this way. Okay? Does that make sense? That's not even problem number 1 yet. Let's do problem number 1. So for problem number 1, example number 1, we're given the inequality x minus 5 can be greater than or equal to 12. And where this comes from is somebody said, hey, we have 5 fewer than a number is at least 12. And you got to be careful. Just because I have the word at least, somebody might think at least means we should automatically use the less than symbol. But at least says that's the lowest value, so we want that to be the lower boundary, and we want all the values greater than that lower boundary. If I were to say at most or the greatest, you got to kind of think that through. So once I have my expression or my inequality, I simply solve like I normally would. Add 5 to both sides, and I get x has to be greater than or equal to 17. That's it. Now I can represent this as a number graph, or a graph on a number line, by simply choosing the point 17. Is it inclusive? So what do I do? Close circle at 17. X can be greater than 17, so what does that mean?
Right.
Now here's a little trick sometimes people get confused. This is an easy problem, so there's no confusion. But I want to use this example to show you a trick that I use. X is a number that's supposed to be greater than 17. Think of a number greater than 17. 23. 23 is over here somewhere. So this is the way or direction that we would go.